The following is a demo of an automation of overlap special medical physics consults. When current treatments are expected to overlap with prior treatments, the planner runs the treatment eval workflow in MIM. If you've ever evaluated this workflow, you'd know that it's riddled with potential failure modes. It's typical to have 3 or more prior treatments and a couple or more current treatments. So you could easily be juggling 5 or 6 or more treatments, and each treatment has a CT, a dose, countless RT structures, etc., etc. And each of these objects are almost never not duplicated in MIM, which keeps copies of things as the planner does their thing. Labeling is also a challenge, as you often have the same labels for things if you're retreating the same region. You have to keep a close eye on timestamps, etc. And as the planner is going through the workflow, she's manually providing countless inputs: alpha-beta ratios, discount factors, numbers of planned fractions versus number of delivered fractions, etc., etc. Just recently, there was a case where the planner falsely assumed that all planned fractions were delivered for a prior treatment. There are also various points of confusion due to different conventions used between various versions of the workflows that MIM has created over the years. For example, discount factors could be a percent or it could be a fraction, and that could cause some confusion. So a lot of failure modes. I'm actually always surprised when a planner pulls it off without errors. My job as the physicist doing an overlap special medical physics consult is to make sure that the final dose accumulations and statistics that the RADONC ends up looking at are not garbage. I do this by running as many sanity checks as I can get my hands on. And that's what constitutes my overlap special medical physics consult report. The report is just the fortification of sanity checks. The way I do this is that I have my own workflow that I created in MIM, independent of the workflow used by the planner. I call it dose sum QA. And it essentially outputs data that my software then grabs and uses to auto-generate the report that you're looking at here. The report starts with a summary table of treatments, followed by a simple explanation of what the planner did when she ran MIM's treatment eval workflow. I make sure to explain which doses have a discount factor applied and which ones don't, because that's a very common point of misunderstanding when evaluating the treatment evaluation report, if you will. What follows is another auto-generated table, and the best way I can describe this one is that it's a table showing how consistent everything is with itself. Now, if you look at a statistics table in the MIM report, they're actually pretty difficult to read. The headers are always separated from the rows, so you have to memorize which column is what as you're reading it, as well as what dose the table corresponds to, whether it's physical or EQD2. And this is in part due to there being way too many structures stuffed into these MIM tables. The dose sum QA workflow that I mentioned earlier that I created lets me choose a smaller subset of regions of interest that are actually of more interest. And those are the ones you see here in this table that's generated by my code. The mean objective has a big advantage QA-wise because we know that, for example, a simple sum of the means across all prior and current plans should equal to the means in MIM's physical dose accumulation. A weaker version of this sanity check still applies to the max dose objective, which essentially says that a simple sum of the maximum across prior and current plans should be larger than or equal to the maximum dose in MIM's physical dose accumulation. Now, this is another example of the type of table we've been talking about, but from an earlier version of my code. It shows that you can also apply more of these inequality type sanity checks, comparing MIM's EQD2 dose accumulation to MIM's physical dose accumulation, depending on the geography of where the prior dose lands relative to current dose. Because prior dose is a dose that's going to have the discount factor applied, and it's going to only apply to EQD2, not the physical, which again is a common point of confusion when interpreting MIM's results. And so physical dose should be larger than EQD2 dose for structures closer to prior dose, because physical does not account for repair essentially. Finally, some of the parameters that are manually inputted into the MIM treatment eval workflow that we talked about earlier are inexplicably omitted from the MIM report. And so to allow myself to check these, what I ended up doing is I had my dose sum QA workflow allow me to add a reference point, so to speak. It's really a structure that's very small, point-like. And then what I do is I compare my own EQD2 calculation of the dose to that structure to that computed by MIM. And that allows me to fill the gap, so to speak, in my QA.